Welcome back everyone. In this lesson we are going to be setting up something that isn't necessarily going to be vital at this very moment, but it is something that we are going to be needing for the future, and this is going to be getting our world mouse position. Because right now this mouse position variable, which if we go down to the onInput function, here we are setting this right here. Now let's go ahead and actually print this out. So if I go to my update function and print out the mouse position variable, and then we run our game and check the console, you'll see here that it gets printed out, okay? The further to the left of the screen I go, the lower that gets, and the further to the right, the higher the X value goes, same with the Y. But this that we are seeing right here, that vector, is not in terms of world coordinates, but rather screen coordinates, okay? Our player at the moment is standing at 0, 0 in terms of world coordinates. Yeah, if I put my mouse over the player, you'll see our mouse position is around 480 by 300. The 0, 0 position for our screen is down here in the bottom left corner, okay? But we are going to be needing the world position of the mouse for two things: for deciding which way our player needs to face, so they're always going to be facing the mouse, and for then shooting our projectiles, okay? When we shoot our projectiles, we want them to be shooting towards the mouse. For both of those things, we need our world mouse position. So how do we actually convert over to that? Well, what we're going to do here in this lesson is just that. So at the top of our update function, here we are essentially going to go get our world mouse position, okay? So let's see how we can do that. First things first, what we need to do is get both our screen width and screen height. So I'm going to create a local variable. I'm going to call this one screen width, and if I go comma, I can define another variable here called screen height. And then if I go equals window.getSize, what this is going to do is it is going to return the width to the first variable and the height to the second variable, okay? So these are going to get the width and the height of our screen in pixels. Then what we need to do is, with that, get the center of the screen, because remember, like I said, our screen behaves kind of differently in terms of coordinates from our world. Our world starts at 0, 0 in the center, and it goes into the negatives to the left and down and positive to the right and up, whereas our screen starts at 0, 0 in the bottom left corner. So to get the central position of our screen, what we need to do is essentially divide the width and the height by 2. So here I'll create a variable called a local screen center equals vmath.vector3. For the x, it is going to be the screen width divided by 2, and the y is going to be screen height divided by 2, and then the z, which is going to set to 0. Okay, so that is how we can get the center of our screen. Now we also need two more things, and that is going to be our camera's position and our camera's orthographic zoom. The reason why is because to calculate specifically where our mouse is in the world, we need to divide our final calculation by the zoom level. So here I'll go local camera pos, and before we actually define this, let's go back into our player collection and detach our camera from the actual player game object. So I'm going to select the camera game object and drag that over collection. So now our camera and player are separate, meaning if I press play, you'll see that my player doesn't actually have the camera following them anymore, and this is just going to be important for when we set this up. Now let's go back to our player script, and we'll go camera pos equals go.getPosition. We can enter in the URL for the camera, which is going to be camera like so. Then we also want to get the camera zoom, so local camera zoom equals the camera.get orthographic zoom, and the camera that we want to access is going to be the camera game object, and then we want the camera component as a child of that, so we'll go hashtag camera then, and there we go. Now what we can do is go ahead and do our world mouse position calculation by going local world mouse pos equals, and this is going to be a bit like this, okay? We're first of all going to have our square brackets like this, go self.mouse pos minus screen center, then divide that by the camera zoom, and then add the camera pos. So this right here is the calculation needed to convert a screen coordinate into a world coordinate with a moving and zooming camera, okay? We also then want to set the Z position of this to be 0, so world mouse pos.z equals 0, and there we go. Now if we go ahead and print this out, world mouse pos, let's go ahead then and run this. What you'll see is that our mouse position is now in world coordinates. So if I hover over the player, you'll see it is about 0, and as I move it away, it is going to increase based on whatever coordinate in the world we are pointing at. Now what we can do in the next lesson is make it so that our sprite is going to flip to face the mouse position. So thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be working on flipping our player sprite based on the mouse position. So if our mouse is over to the left, we aren't going to flip our sprite because it's already facing to the left, whereas if our mouse goes over to the right, it is then going to flip its horizontal state. So to do this, let's go to our player script, and underneath where we are getting our world mouse position, we need to create a new variable which is going to be our mouse direction. And let's actually define that up here. So where we define our variables, we'll go self.mousedir for direction equals vmath.vector3. And this right here is going to be the direction relative to the player that our mouse is going to be pointing at. So down in the update function, I can go self.mouse direction equals, and this is going to be equal to vmath.normalize, and we're going to normalize the world mouse position subtracted by the go.get position. Okay, so here we are essentially subtracting our position from our world mouse position, and then we are normalizing that. So now this is basically going to be a direction relative to the player that the mouse is pointing. And then to flip the sprite, we can do that right here. So we'll go flip sprite. What we're going to do is we're going to go sprite.set h flip, so set horizontal flip. We need to give it a URL, which is going to be our sprite URL. And to do that, we can simply go hashtag sprite. Remember, the hashtag essentially means we are accessing a component attached to this game object, and that component's ID is sprite. So if we go to our player collection, you'll see we have our player game object, and we are accessing the sprite component, okay? So then for flip, this is going to be either true or false. So I'm simply going to create a condition here, which is going to be our mouse direction.x, and then we'll go greater than 0. So if our mouse direction.x is greater than 0, meaning the mouse is on the right-hand side, it's going to be true. Otherwise, it will be false. So now if I run this, we should see that our player is going to flip its left and right direction to look at the mouse, which is very cool. Okay, so we got that all set up. Now, in the next lesson, I think we should probably be setting up our camera, because right now our camera is kind of static. We did have it following the player before, but to have it set up for the future, we really need our camera smoothly following our player around, okay? So that is what we're going to be working on in the next lesson. Welcome back everyone. In this lesson, we are going to be setting up our camera follow script. Essentially, this is going to make it so that as our player navigates around the level, the camera game object, which is also here in part of the player collection, will follow. But it's not going to snap to the player's position. Rather, it is going to smoothly transition to them to basically make the movement feel a bit nicer. And then the second part of the camera follow system is going to be clamping the camera's position, essentially making it so that the camera cannot go beyond the bounds of our level. So to begin, let's go ahead and create a new script. I'm going to go down to my player folder, right click on it, and go new, script, and I'm going to call this one camera controller. Just like that. Now, inside of this camera controller, we are going to keep the init function, delete final, keep update. We're going to delete fixed update, keep on message, and delete the final two. Okay, so the init, update, and on message are the three functions that we're going to keep from the default list. Now this camera controller script, if we go over to our player collection, we can select the camera game object, which has that camera component inside of it, and we're going to right click on it and go add component file, and we're going to attach that camera controller script like so. Now, back inside of our camera controller, what we're going to do is we are going to, first of all, go to the init function and create a variable, which is going to be called follow pos. Essentially, this is going to be the position that the camera is going to try and get to each frame. It's going to be moving towards this position. So we'll make it a vmath.vector3. And as you may have guessed, this follow position is indeed going to be the player's position. So how are we actually going to set this? Well, the way we're going to set this is every single frame, the player script is going to send a message over to the camera controller, essentially telling it the position to follow. So here in onMessage, we're going to go if the message ID is equal to, and the message we can call, for example, follow, and then if that is the case, we are going to set our follow position to be the messages follow pos. Okay, so that follow pos is going to be the data we'll send over. Now let's set this up now so we can actually get it working. So let's go over to our player script, and inside of our update function, let's just go down here at the top somewhere, and I'll create a little comment called camera follow. And here essentially what we're going to do is we're going to post that follow message. So msg.post, and here we want the receiver URL to be our camera controller script. So let's go to our player collection, and if I select the camera controller script right here, you'll see we first, from our player object, have to access the camera game object, then the camera controller component. So to do that, we are simply, as the receiver URL, going to go camera hashtag camera controller. Then the message ID, remember that one is follow, and then we can send over some data. So I'm going to have an opening and closing squiggly bracket right here. It's going to go to a new line to make it a bit neater, and we're going to define the follow pos data to be equal to our player's position. So .go.get position, and there we go. So now if we go to the camera controller script, inside of update, let's just quickly go ahead and print out self.follow position just to see if it works. I'll bring up the console here, press play, and as you can see, as the player moves around, that follow position is being changed to be the player's position. Okay, which is great. Now to actually set this up, let's first of all make it so that the camera is just going to follow the player's position directly with no smoothing. So for that, we need access to the camera's position. So local pos equals go.get position. We then want to set our position to essentially be the follow position. So pos equals self.follow pos. And then we want to set our position again. So go.set position, and we'll set that to be pos. Now, if I run this, we should see that the camera is going to be the player's position, okay? So the camera is going to follow the player around. But as you can see, it's kind of snappy. We do have a bit of a weird offset when the player moves, but we want to make it so that the camera is going to smoothly transition to the player. So to do this, we are going to use what is known as linear interpolation, okay, or lerping. Essentially what lerping does is you give it a current value and then a target, and then the amount that you want it to essentially interpolate between those two values. And we can adjust that interpolation value to define how quickly or how slowly the smoothing is. So here where we go pos equals self equals the follow position, we're instead going to make it equal to vmath.lerp. And lerp here, we have a t, n1, and n2. T is essentially the delta. For this, I'm going to go 15 times dt. Now we're multiplying this by delta time because we want this to be frame independent. And 15 is just a random number I'm putting in. We can of course adjust that later on. We then enter in the from position as n1, which will be pos, and the to position, which is going to be self.follow pos, so the position that we want to get towards. Now if I run this, you'll see that the camera is going to smoothly transition and follow the player, which looks nice. Now we can make this effect be a bit more smoother by lowering the number. So if I make this 5, you'll see that the camera is going to take a lot longer to catch up to the player's position. but I think 15 is a good number here. So there we go. That is how we can set up our cameras following. Now, what we're going to do next is work on setting up the boundary, essentially make it so our camera cannot exceed the boundary of our level, so we don't see any blackness beyond our tile map. So the way we're going to do this is by essentially clamping our camera position, and to do this we are going to need a vital function, and that is a clamp function. Now a clamp function, essentially you give it three values. You give it the value you want to clamp, a minimum, and a maximum, and basically that function will return that value that you gave to it clamped or restricted between the minimum and the maximum. So I'm going to create that function here just above update. So I'll go local function, I'll call it clamp, and then the three parameters we're going to have is going to be value, min, and max. Now inside of this function we essentially want to check to see if the value is less than the minimum. Then what we're going to do is we're going to return the min. Else if the value is greater than the max, then we are going to return the max. Otherwise, we can safely return the value that was already given to us, okay? So you can see here, we're essentially creating a function that restricts a value from getting too low or too high. And inside of update is where we will then put that into action. So I'm just going to add a little comment here, which just goes camera follow. And then down here, we are going to go camera boundary, okay? Now, before we actually define the code for this, we need to know what our boundary is, okay? So how far can our camera actually go? Well, to do this, I'm going to go into our game here. I'm going to select our player just because it's a little visual marker, and I am going to move them over to the leftmost boundary here, okay? So this is going to be the furthest the camera can get in terms of its left-hand side. So what we're going to do is then look at the X position, which is minus 480. Okay, so 480 is going to be the furthest left that the camera can go, and thus, since this is a square, it will also be 480 for all the other directions. So what I'm going to do is I'm going to go to the top and create four new variables. I'm going to create a variable called left boundary, which is going to be equal to minus 480. We then want one for the right, up, and down. So here we'll go right, which is going to equal positive 480. We then have the up boundary, which is going to equal positive 480. And then we also have the down boundary, which is negative 480. Now, if you did have a rectangular level, then these values will be different. But take those measurements yourself just to make sure. Okay, so we have our boundary variables here. Now down inside of update, there are going to be a number of different steps we must follow before doing the camera boundary, okay? So step one, what we need to do is get the center of the screen, okay? So here we'll go get screen center. Then what we're going to do is we are finally going to clamp the position, the camera position, okay, to the boundary. So these are the two steps we're going to do, and in the next lesson we'll go through them. So thanks for watching, and I'll see you all then. Alright, welcome back everyone. So in this lesson we are going to start by getting the screen center. Now why are we doing that? Now the reason why is because we aren't going to be clamping the camera based on its position, and I'll show you what I mean by that. So if we go out to our game here and we select our camera game object, we want to make it so our camera cannot go beyond the bounds of our tile map. But if, for example, we clamp our camera's position directly based on those bounds, then our camera, for example, will not be able to go beyond this X position. But since this is the center of our camera, our view would then look something like this, okay? Half our screen would be in our level, but the other half would still be outside of it. Now, we could, of course, find a value in here to clamp the camera in, but that would then make it so that different resolutions would stop at different positions, okay? So what we need to do is get the center of our camera, and that will allow us to automatically then offset from the left-hand side, for example, to clamp it so that the left-hand side of our camera will always bump up against the very edge of our level, no matter the resolution, okay? So That is why we need to get the center position, because we'll be subtracting it and adding it to the boundaries, okay, to get our new adjusted boundary with that, I guess you could say, margin in place. So to get the screen center, we first of all want to get the screen width and height. Now, we've already gone ahead and done this before in our player script. We're going to create two local variables, screen width and screen height, and these are going to be equal to window.getSize. Then what we want to do is get our camera's orthographic zoom. We've also done this before, so we'll create a local variable called zoom, and this is equal to our camera get orthographic zoom. The URL for that is simply #camera, because remember, this script is attached to the camera game object, which has the camera as a component. So we simply go #camera for that URL. And then for the screen center, we can go something like this, equals vmath dot vector 3. Now for the x, we're going to go screen width divided by 2 divided by zoom. Now we're dividing by the zoom because the screen width is going to be the same no matter the zoom level. So if the camera zoomed very far in, that screen is still going to have the same width in pixels. So we divide by zoom to get a sort of world camera width. Okay, so this is essentially going to get the camera's center as a world position. Then for the y, we're going to go screen height, divide by 2, divide by zoom, and then 0 for the z. Now, if you're wondering why we're dividing by 2, that is of course because we want to get the center of the screen, so half of the camera's width and height is going to be a point right in the middle. Now that we have that, we can go ahead and clamp our camera's position. So I'll show you how we do that. Essentially, we go pos.x equals clamp. Now, we're calling that clamp function we created in the previous lesson, and we want to give it a value, which is going to be pos.x. Now, the minimum, this minimum is essentially going to be our left boundary plus the screen center along the x-axis. So I'll show you here. So we'll go left boundary. And before we do that, let's actually have a look at if we just give it the left boundary and the right boundary, okay? So we're clamping our x position between the left and the right. And then let's, of course, set our camera's position to be that new pos. Okay, so now if I go ahead and run this, we'll see this in action. So the camera follows as usual, but you'll see that if I go all the way over to the left here, the camera stops at the left boundary. And this was the issue I was talking about before. So what that screen center offset does is essentially makes the minimum clamp value, this boundary, plus the screen width, or plus half the screen width. So here, what we can then do is go left boundary plus screen center.x, and then the max is going to be the right boundary minus screen center.x. Now, if I go ahead and run this, you should see that, again, if we go over to the edge, the camera now stops at the very edge here on the right-hand side. Same thing, or on the left-hand side, and same thing if we go over to the right. Now, let's do the exact same thing, but for the y. So I'll go pos.y equals clamp. Pos.y for the value. The min is going to be the down boundary plus the screen center dot y, and the max is going to be the up boundary minus screen center dot y. So now, as you can see, we can have our player move around the level, but the camera will never exceed the bounds of said level. Okay, so that is how we can set up a nice camera controller script inside of Defold for our game. Hey everyone, in this lesson we are going to start working on our projectiles. Now these are the objects that the player is going to create and then launch out towards the mouse position. Now a projectile is going to be represented by a game object, and then we are going to use factories to essentially create these projectiles from the player game object and then shoot them out. So let's go over to our entities folder, right click, go new, and we're going to go up to where we have game object right here. I'm going to call this one projectile, and inside of here we need to create a few components. First of all, a sprite to actually see what we're looking at. So I'll go add component, go down to sprite. We'll set the image here to be the tile source. But then we need a default animation. Now for this, let's go over to our sprite sheet, and we are going to go to the outline, right click on tile source, go add animation, and we are going to call this one projectile, just like that. Now what actual sprite are we going to use for our projectile? Well, I'm going to probably choose a fire sprite, so one something such as down here. There's plenty of them. Depending on your sprite sheet, of course, feel free to go ahead and figure that out. So I'm going to set the start tile here to be 1903 and the end tile to also be 1903, which is a sort of flame sprite. Back inside of our projectile, we can then set that default animation to be that right here. But what you'll notice is that the sprite is a bit offset. So what we're going to do is simply just move it so that the sprite image itself is in the middle, not the origin of that component. Next, let's go ahead and add in a collision object so we can actually have the ability to detect collisions. And on this collision object, we are going to change its type from dynamic to trigger, essentially meaning that this object is going to be controlled by the script, and it is not going to be a collider in the sense that it's going to bump up against things, but rather it is going to go through and detect triggers, okay? Sort of like an overlap. Let's right click on collision object, add shape, sphere, and we can then resize this to see something such as that right there, 10. Okay, so we have our projectile pretty much set up. Now we just need to attach a script. So in entities, we're going to create one more asset, and that is going to be a script called projectile. And then of course we can go ahead and attach that as a component. So right click on game object, add component file, go down to projectile, and OK. And there we go. Now, over inside of our projectile script, we are going to keep the init function. So I'm just going to remove the comments, delete final. We can also then keep update, delete fixed update, keep on message, and then delete the other two here. Okay, and there we go. So these are the functions we are going to be using. Now for our projectile, we also want a variable, so local, and I'm going to call this one speed, and this will be 200. So this is essentially how many pixels per second is this projectile going to move at. Now inside the init function, we can set up some variables. So I'm going to then create one called move direction, which is going to be a vector direction, so vmath.vector3. This will be given to us when the player spawns the projectile, basically then telling it which way it should move. And then another variable called timer, which is going to equal 2. And this is going to be the lifetime of the projectile. Essentially, it is going to survive for 2 seconds. Now what we're going to do is actually make it so our player can spawn these projectiles. Now to do this, we're going to go over to our player collection, right click on the player game object and go add component, and go over to where we have a factory. Now a factory is a component that essentially can spawn in game objects. I'm going to rename this to be projectile factory. So projectile factory like so. And the prototype is essentially the game object it is going to spawn in. So I'm going to open this up and select our projectile. Now if we go inside of our player script, we can set it up so that whenever we left click, we are going to shoot. Now to do this, I am going to create a new function. So just below update here, let's create a new function. So local function, and this is going to be called try shoot, and it's going to have self sent over, of course. So the try shoot function, essentially when we left click with our mouse, this is going to call. And the reason it's called try shoot and not just shoot is because this function is going to be called every time we press the left mouse button. It is then going to check to see if we have the ability to shoot, so has enough time elapsed since we last shot. If so, shoot, otherwise don't. So let's connect this function up to our left mouse button. Now, if we go down to the on input function, remember on our input map, we had that shoot input. So here I'm going to simply go if action ID equals hash shoot, then we are going to call try shoot, just like that. Okay. Now inside of try shoot, let's print out the word shoot to just make sure it works, and then run this. Okay, there we go. Let's pop open the console here so we can have a look. And now if I go ahead and left click, you'll see shoot. And every time I press it, even when I'm holding down my mouse, you can see shoot is being called many times, up to a couple hundred at the moment. But we don't want to be shooting every single frame, okay? That is going to create a lot of projectiles and a lot of lag. So we are going to make it so that the player can only shoot perhaps 10 or 5 times per second. So up here inside of the init function, we are going to go ahead and define those variables. So first of all, we need a timer. So we're going to create a variable called timer, which will be equal to 0. And this is essentially just going to count up in seconds. The reason why is because whenever we shoot, we are going to basically keep track of the last time that we shot, and then whenever we want to shoot again, we are going to make sure that the time between now and the last time we shot is greater than our shooting rate. Okay, so I'm going to create a self variable here called last shoot time equal to 0, and then also a variable called shoot rate, which is going to be equal to 0.1. Okay, 0.1 meaning we can shoot every 0.1 seconds. Now, down inside of update, I am simply going to make it so that the timer is going to increase by 1 every second. So here we can go timer equals timer plus dt, which is delta time. So basically, if we increase by dt each frame, it's going to be basically going up second by second. Now, inside of try shoot, we want to make it so that if we have shot within the last 0.1 seconds or whatever our shoot rate is, then we return. So I am simply going to go if the timer minus the last shoot time. If that is less than the shoot rate, then we are going to return, okay, like that. Now, otherwise, what we're going to do is we're going to print out shoot again, and we're also going to set our last shoot time to be equal to the timer's current value. Now, I'm going to pop over in the console, I'm going to press play, and let's see what happens when we try and shoot. So now you can see that that shoot print, which it's pretty hard to see down there in the video, but it is going up a lot slower. It is going up once every 0.1 seconds. So we are now shooting at a consistent rate, not every frame. Alright, so in the next lesson, we are going to make it so that instead of printing out shoot, we are instead going to create a new projectile, set its position, and then shoot it off in our mouse direction. So thanks for watching, and I'll see you all then. Alright, so let's set it up now so that when we shoot a projectile, we aren't just printing out a line of code, but rather we are spawning in a new projectile. So inside of the try shoot function, what we're going to do is I'm going to start off by creating a local variable called proj, which stands for projectile. And this right here is going to be equal to factory.create. Now with this, we basically need to give a URL for our factory. Now if we go to our player collection, you'll see that the factory is a component of player, so we simply need to go hashtag projectile factory. So here we'll give that URL, projectile factory, and if we add a second parameter, we can actually give it a position. So I'm going to set it to be our player's position, so go.get position, like so. Now let's see if this is going to work. So we'll run this, and we can left click, and as you can see, each time we left click, it is going to spawn in a brand new projectile, which is pretty cool. But at the moment, you'll notice that the main thing, we don't actually have these projectiles moving. They're kind of just sitting there in space. So let's make it so that our projectiles can actually begin moving in the direction of our mouse. Now we are going to do this by sending a message over to the projectile, and this message is going to have the ID of set direction, and we'll be sending over our mouse direction vector. So for this, I'm going to go msg.post. The receiver is going to be the projectile we just spawned in, so we'll use that proj variable. The message ID, we can define this as set direction, our own custom little message. And if we add a comma, opening and closing squiggly brackets, we can then define some properties that we want to send over through the message. Now, we're only going to send one, and that is going to be the move direction. So we'll go move equals our mouse direction, just like that. Now let's make it so that the projectile can then actually receive this message and then run code respectively. So over inside of our projectile script, what we're going to do is go down to the onMessage function, which gets called whenever a message has been sent to the projectile. And we're going to check to see if the message ID is equal to that set direction message. Whoops, set direction like so. Then what we're going to do is we are essentially going to set our move direction variable that we have defined here in init. So we'll go move direction equals message.move direction. Just like that. Okay. So we've set our move direction. Now we actually need to move our projectile along this vector. Now we've done movement already with our player, so we should be able to do that. So we simply, first of all, in the update function, want to get our current position. So we'll go local pos equals go.getPosition. Then we want to increase our position in the move direction at a rate of speed. So here we will go pos equals pos plus the move direction times move speed times speed times dt for delta time. And then finally we can set our position to be the new one. So go.setPosition pos. Okay, let's now run this and see if it works. So as you can see, every time I shoot now, we are basically having the projectiles launch out in that direction. But there's one more thing that we need to do to finalize our projectile shooting, and that is not collision detection just yet, because we don't really have any enemies in the game, but rather setting it up so that these projectiles destroy after a certain amount of time. Because if I shoot and then follow this projectile, you'll see it kind of just keeps on going on forever. Now, the big reason why we don't want that to happen is because of performance, okay? If I'm here shooting all these projectiles around, they are going to keep on flying out forever, okay? And we don't want that. We want the projectiles to delete themselves after a certain amount of time, which, as you can see here, we have set a timer variable to be 2. Now, down here inside of update, what we're going to do is every frame basically subtract from timer, so it goes down in seconds. So here we'll go self timer equals the timer minus dt, and then we'll check to see if the timer is less than 0, then we want to destroy this object. So we can go delete, and there we go. So now if we run this, you should see that when I shoot a projectile, and after 2 seconds, they will be deleted, okay? So they're no longer going to take up memory space if they keep on being shot outwards, because otherwise, you know, that's going to take up a lot of space in memory, and Defold also has issues when you have too many sprites being rendered at the same time, so we aren't going to run into any of those issues either. Now this is where we are going to leave our projectile script for now. In the future, once we create our enemies and our damage system, we will then return here to implement the ability to actually damage enemies. But for now, that is everything with our projectiles done. And in the next lesson, I think it's going to be a great idea to start on creating our enemies, okay? These little creatures that can then chase after and attack the player.